Okay, so I've cut that USB cable in half, and I have the USB full-size piece here, which I've plugged into my USB power supply, so I am getting power across these. Now, we're going to make an assumption that the red is the positive, and so we're just going to go through and touch each one of these wires to make sure that we're getting a voltage. So red to black gives me a voltage, and then we'll do red to green. Touch that, and red to green gives me 5 volts, and red to white gives me 5 volts. So the red is definitely my positive. So now we'll just make sure that the white to black doesn't give me any voltage, white to green doesn't give me any voltage, and green to black doesn't give me any voltage. So we know that the red is the positive, and we're just going to make sure that the way that this is mapped to the actual USB cable is going to be correct, because there's only 2 pins that are going to be sending the voltage to the Raspberry Pi, and then 2 pins that are going to be sending data. So we do not want to send voltage over the data lines. I've quickly reset and I've unplugged it, and now I'm just going to map the pins inside the connector itself, and we're using the full side, using the resistance meeting. So if there's no resistance, I will get a beep, or I'll just get a measurement from my tester. All right, so that's turned on, and perfect. I am getting a thing saying that I have no resistance, and so that's how we're going to tell what each pin does in here. So I'm going to slide the pin in, and I'm just going to connect to each side. This is going to be important, as I said, just because we do not want to send voltage over the data line. So I just need to know which ones are which. And so we're testing the white, the red. Oh, and I did get a hit on the red. So I know that the first pin in here is the red. So that's going to be my plus 5 volts right there. So now I want to do the second pin. And in the layout, these 2 middle pins should just be for data. So we're going to determine which 2 are the data lines. So we'll do the white one first, and I got voltage on the white one, which means that that second pin is white. Okay, so I know the first one's red and the second one's white. Now it's just going to be a matter of determining what that second data color is, so that we can just map it. Not all USB cables use the same color coding, which is why we're going through the process of actually taking and doing this one. All right, so am I getting anything? I'm not getting anything on the green. Let me just try to get it in there again. This is why we're using the bigger connector, just because it's really hard to get anything in the micro connector. So it will be the same color. Okay, so we know we got positive on green. So now it's red, white, and green, which means that the final one, which should be my ground, is going to be the black. And it is, so that's correct. So this works out perfect. The ground is also the sheath on this. So we're going to be using the red and the black in order to power the Pi. So now we know what that's going to be in the micro one. And so I've just taken, I've mapped it out here so that I know exactly which ones the USBs are according to this cable. And as I said, it can vary by your cable, so make sure that you map yours out accordingly. You do not want to mistakenly throw voltage along the data lines to the chip, or else you can damage it. Now we're going to grab the power supply, and we're going to tin the ends of it. So I've cut this in half again, or not exactly in half, but just enough so it'll fit up the wall. So this is the length of it from the actual power plug itself, and I've cut the very tip of it so that that's going to go from the power converter that we're going to use into it. Just to make sure that we've got everything color coded, I'm going to plug this in. Red should be my positive voltage in this case, and white should be my ground. So once we plug it in, I'm just going to put my test meter on it, make sure that I'm testing for DC voltage, and then line up my probe so the red is on the red and the white is on the white, in which case I should get a positive number. And I do get a positive number of 12 volts on the nose. So now we're going to take these and we're going to connect them to the converter, which is going to convert it from 12 volts down to 5 volts for the Raspberry Pi. Here is my converter. So we've got all the components. We've got the other end of the USB cable. We've got our power supply. We've got the connector that's going to go into the monitor. I've tinned all the ends of the wires. So now it's just a matter of connecting it to this 12 volt DC to 5 volt DC converter. This is just a very convenient piece. It means we're only going to have one wire going up the wall. So we want to connect the red to the positive, which we know. And then we're also going to loop this out because the monitor is getting 12 volts. So we're going to go red to red on this, and then we'll do white to the negative, and we'll do white to white. This is going to pass the 12 volts DC through because that's the voltage that the monitor is going to require. And we're just going to slide these bits in here. You want to make sure that they get a good grip, because once we connect these to the backside of the monitor itself, we want to make sure they don't come loose. So put a good screw on there. And that's going to be my 12 volt feed through, and also the 12 volts going to the DC converter. This is a very convenient piece. It's mostly used in cars, and just look it up. It was $10 to purchase, but saving not having to run two wires up is going to make this look a lot slicker when it's on the wall itself. Now that we got that ready and done, now we're going to plug in the micro USB, which is going to power the Raspberry Pi. We just have to make sure we do it correctly. Again, we mapped, and we know that the red is going to be the positive, and in this case, the negative or ground is going to be the black wire. It's always different per cable, which is why I took the extra steps to go through and to measure and voltage everything. And now we're going to put this together on the back of the monitor.